Okay, so today we are talking about congruent triangles, and more than that, just kind of congruent polygons in general. So, starting off, our game plan today is we want to be able to, at the end of the day, say I can name and use corresponding parts of congruent polygons, and I can prove triangles congruent using the definition of congruent. So, moving on from there, congruence means it is the same size and the same shape, down to every single part. So a line that is 4 inches is congruent to another line that is 4 inches. Likewise, which we'll get into this more, but like if a square has sides that are 3 inches and there's another square with sides of 3 inches, then they would be congruent because all their sides are 3 inches on both figures, and all the angles on both figures would be 90 degrees. So just like congruent being the same size, same shape, congruent polygons are also same size, same shape. So it's just kind of a more specific thing. Corresponding parts. So those are the parts that make up the shape. So like the line segments that make up the sides and the angles. And so lines and angles on congruent polygons that are congruent. So they're the ones that are exactly the same. So as we get into this, we have our definition of congruent polygons here, more specific than what I gave you. Feel free to put this in your notes. But I am moving on. You can pause the video at this point if you'd like. So first kind of type of problem we're going to see is where they want us to write a congruent statement. So what this problem says is to show that the polygons are congruent by identifying all of the congruent corresponding parts, then write a congruence statement. So none of these sides or angles are labeled as the same, but since they want us to write a congruence statement, we're just going to kind of assume that they are congruent since they look congruent. So there are some tips and tricks to this when it comes to writing the congruent statement itself, but big picture, the important thing to me is we want to label what sides are the same. So I'm going to start off by labeling the sides. And side AE is the same as side RQ. Side AB is the same as side RT. BC is the same as TP, which we can tell just kind of by looking at these. There are situations where they'll have actual measurements on them. This problem just does not. CD is the same as PS, so we're going to give those 4 hash marks. And then ED is the same as QS, so I'm going to give them 5 hash marks, which these are a lot of hash marks and more than we would usually see in a problem. But I feel like it's easier to label the shapes than to actually write out individually, like line AE is congruent to line RQ. Now, if you would prefer to do that for each of these lines and each of these angles, please feel free. I personally do not wish to do that, so I'm just going to label them all and then write my congruence statement for the whole shape at the end. So likewise, as we continue, angle A is going to be the same as angle R, so they are congruent. Same with T and B, P and C. And I'm thinking you kind of get the gist, but S and D are also the same. It's harder to write all these little individual lines. And then E, we're just going to pretend like that's 5 cohesive lines. And Q are also congruent. So it's kind of a mess doing it this way, but it's less work than writing all of these out individually. And like I said before, you could also say angle A is congruent to angle R, and do that 5 times for AR, BT, CP, DS, and EQ. I prefer not to. So this is how I'm doing it. I'm perfectly fine with you doing it the way I did it, or writing each of those individual parts out if you so choose. So Now, when we're writing a congruence statement, what that's going to look like is we are going to write out, we're not going to write out, we're going to write out like polygon ABCDE is congruent to polygon RTPSQ. And the important piece of this is, which let me write the first one down and then we'll go from there. So I would say A, B, C, D, E is congruent to. So what is important in this is to keep the same order. So how angle A is congruent to angle R, and then B is congruent to T. So we have to keep that order. So if we were doing a lap around this and we wanted to start at A, we go A to B to C to D to E. So that's kind of our order we go. So we wrote A first, B second, C third, D fourth, and E fifth. So we have to do the exact same thing on this second polygon. We have to start at R, go down to T, go over to P, go up to S, and finish off at the top with Q. So we have to keep that same relative order when we're writing these congruent statements. And there is a reason for this, and we'll get into that a little bit more later. But for now, we just need to know that we have to keep everything in the same order. And really the reason for that is it makes life a lot easier in the future. Fun fact, a little foreshadowing there. But I'm going to teach you guys a couple tricks that you can do when you're doing these problems that are just going to make your life so much easier once they start turning shapes and flipping shapes and making it harder to see that they're congruent. Right now, they're right next to each other, they're oriented the same way, and it's pretty clear that they're congruent, but in the future, they're going to kind of turn stuff and make it a little more difficult on you. But I'm going to show you some tricks to kind of help with that. So long story short, our congruent statement is right here in the green. Important, we have to write it in the same order. Write in same order. That's French for order, fun fact. It's not, but you know, it's Mr. Wright's French for order. So our next problem, what they say in this is the support beams on the fence form congruent triangles. In the figure, triangle ABC is congruent to triangle DEF. Which of the following congruent statements correctly identifies corresponding angles or sides? Okay, so here's the tricky part. And this figure is kind of a lot, so I'm just going to color in, or I'm going to try to if my hand's, shaky enough. So I'm going to color in triangle ABC, and then in green, I'm going to color in triangle DEF. So, like I said in the last problem, we have to keep these in the same order. So these two triangles are actually not oriented the same way. If we wanted to orient them the same way, then we would have to take DEF and we would have to turn it 180 degrees. So DEF would actually look like this. If Mr. Wright could draw a even remotely close triangle, DEF would look like this, DEF, because when we write this congruent statement that they wrote up top, they said triangle ABC is congruent to triangle DEF. So we started on this triangle ABC. We started in the upper left, went down, and then went back up. So we went down and then back up. So it needs to follow that same pattern in the second triangle, so we would actually need to kind of flip that, the second triangle to where DEF, we go down and then back up. And so they want us to write congruent statements, and they want to know which one. Okay, pause. they want us to identify which of the following congruent statements is correct or correctly identifies corresponding angles or sides. So let's look at the first one. So they say angle ABC, so we're going down and then back up, is congruent to EFD, which EFD, if we look at our new triangle that we turned so it's facing the right way, EFD goes up and then to the left. So that one would not be written correctly because it doesn't follow the same pattern. So that one's a no-no. Then we have angle BAC, which goes up and then to the right, and angle DFE, which goes right and then down. So if you notice when I'm showing the directions they're going, I'm starting at the left and I'm working to the right. So we start at B, we go up to A, and then we go to the right to C. So we're reading it chronologically, so we're going from left to right. And so those also do not follow the same pattern. So that second one would be false. So if we look at our third one, that's a line. So we have line BC, which starts at the bottom and goes up to the top. So this line here. And we have line DE, which starts in the upper left hand and goes down to the bottom. So that one would also not be true. And then our final option, which must be true because none of the other ones were. Oh no. Let's see if I can get that. There we go. Our final option, which we know has to be correct because the first three weren't, is AC, which is this line that goes from the top to the right, and DF, which goes from the top left to the right. So it's that top line as well. Since those are in the same position, we would say D is true. All right. Now, I'm going to introduce you to my trick. We're going to look back through these options. We're going to keep D circled for now just because we know that's true and that's our correct answer. But so the nice thing about, you see in this congruent statement how they say A, B, C, and that's the pattern both triangles need to follow. So A, B, C, A, down to B, up to C. D goes down to E, and then up to F, just like the first one does. So they follow the same pattern, the way they're written. So we know, based on this first statement alone, that line AB is congruent to DF just because of the way they're written. So, you know what, let's pause. Let's go back a little bit. So let's look at the angles first. So angle A, the first position in the first triangle ABC. So that first angle is A. That angle is congruent to angle D because they're in the first position in that statement. Likewise, angle B and angle E are also congruent because they're in the second position. And if we check that, angle B and angle E are both on bottom of our figures. So that checks out. And then angle C and angle F are also congruent because they're our last points. So looking solely at that congruent statement, we can solve this problem without the picture at all. So if we try that, we're going to black out this picture. No more picture. We don't need it. And we look at it, angle ABC, so in the same order as this first congruent statement, A, B, C, and EFD. Okay, EFD doesn't follow that same pattern, so we know that one's not true. If we look at the second one, BAC, so we go 1 is in the middle, 2 is on the left, and 3 is on the right. If we look at DFE, we have 1 on the left, 2 on the right, 3 in the middle. So those don't follow the same pattern either, so we know that one is also false. And then if we look at line BC, it goes line B, C, so 1, 2, our second and third place in that first congruent statement is congruent to DE, which DE are our first 2 points in our congruent statement on the right-hand side, so we know that one cannot be true because they're not in the same place. But if we look at AC and DF, so AC is the first place, then the third place, and if we look at DF, D is the first place, F is the third place. Those are in the same order as they are in the congruent statement, so that one must be true. That's a quick way to check these just by using the congruent statement alone up at the top. I know that's not going to work for some people. Some people's brains just don't work like that. So you can always use the picture still. But if it works for you just looking at that congruent statement, it's going to cut a lot of time off of these see if these sides are congruent thing. Okay. Onward and upward. So, in the diagram, triangle ITP is congruent to triangle NGO. Okay. So if we look at that, these are kind of a little bit askew, but triangle I, so 1, 2, 3 is congruent to triangle 1, 2, 3. So we go that same order. So if you wanted to redraw this to kind of clear it up and make it a little bit easier to see, that's totally okay. Now, if you're thinking to yourself, Mr. Wright, you're not really going to attempt to draw that because we know your drawing skills are lackluster, you would be wrong. I am going to attempt to draw this because my drawing skills are, well, still lackluster. But we're going to give it a go. And I'll tell you what, that is actually pretty decent. So the way we're going to label this is NGO. And then I'm also going to erase all of that because we don't need that anymore. So I'm going to copy the labels down as well. So side NG would be X minus 2Y. And then angle O would be, not on that slide, would be 6Y minus 14 would be this angle here. Okay, so they want us to find the angles or the values for X and Y. So the easiest way to do this is to set up the corresponding parts because they're going to be identical. So, or they're going to be congruent. So, let's see. That has an X and a Y in it. So we're not going to be able to solve that right away. So the first one we're going to be able to solve is to say that this 6Y minus 14 is equal to 40 because they are corresponding angles. And if we look at our congruent statement, we know P and O are both the last thing in the congruent statement, so we know those two are congruent. So what I would do is I would set these equal to each other. So 40 is equal to 6y minus 14. And then you would have to solve this. So in order to solve this, we need to get the y by itself. So we're going to add 14 to both sides. And we, of course, add that to both sides because we need to keep the equation balanced and happy. So 54 equals 6y. And then we divide both sides by 6. Keep the equation nice and balanced, and so we end up with y equals 9, or 9 equals y. So, knowing that y equals 9, first of all, that's half our answer, so we can circle that and be happy with ourselves for accomplishing that. So now that we know y equals 9, what we can do is we can try to solve the second piece, which is this side NG, which is our first two, and side IT. So those two are corresponding. So I'm going to highlight that side in blue. So we have this side here and this side here are congruent. So what we're going to do is we're going to set the values of those sides equal to each other. So we have 7.5 is going to equal x minus 2y. Now, we already have the y value, so we're going to have to substitute in that y value. So if we substitute in, we still have 7.5 equals x minus 2 times 9. So if we work that out, we end up with 7.5 equals x minus 18. Now we can go ahead and start solving this, which in order to solve this, we have to get the x by itself. So we add 18 to both sides. Of course, we're still adding to both sides because we have to keep that equation balanced and happy. We don't want angry equations in here. So 18 plus 7.5 would be 25.5 equals x. Awesome. So we have our second variable, and we've solved the equation. Now, if you wanted to, you could plug both of these variables back in, double check that this equation here equals 7.5 and that this equation here equals 40. I know we're right, so it's not necessary. However, if you did choose to do that, that would be totally fine. That would be a good way to try to make sure you get all your points. Okay, so we're moving on. Okay, this is another type of problem that you're going to see a ton of. So in the diagram, FHJ is congruent to HFG. Now, you're going to see a lot of these, and a lot of these are actually going to end up being in proofs, which I know we love proofs, but that's fine. And the reason a lot of these are in proofs is because they like to trick you. They will never give you the side length of this middle side, but you know that these two are congruent because they're the same line segment. So that's a way they like to try to trick you. And if we look at that, FH and HF are the first 2 points in each of these congruent statements, so we know those two lines are the same because they are the same line. So anyway, after that caveat, what I'm going to do again is you know what? We're not going to redraw the triangle this time. We're going to label our corresponding parts. So I already labeled those lines in the middle. I'm going to label JF is congruent to, so JF in this first triangle, or FJ, so the first, then the third, is going to be the same as HG. So those two lines are congruent, which means that line and that line must be congruent. Now, for our angles, we're going to be looking at angle H, which is going to be the same. It's in the second place on the first equation, is going to be the same as angle F. So H is the same as F, which I need one. Okay. I think that's all the information we need. Yeah, it looks like it. So what this is telling us is that, let's get the old highlighter tool out. So what this is saying, angle H and angle F are congruent. So I'm going to highlight them in yellow. So those are congruent. We can set those equal to each other. And then the other ones that are congruent would be, let's use orange, would be this one and this one. So we can go ahead and solve both of those. Let's start with the x. So we would say 6x plus 8 is equal to 35. And then we go about solving this equation. So we subtract 8 from both sides, keep the equation balanced and happy. which would leave us with 27 equals 6x. I don't like where this answer is going already. Divide both sides by 6, and we are left with x equals, I believe, 4.5. Yeah. Messy answer. Not my favorite one. But you know what? That's the first piece of our answer, which means we're done with that and we can move on. So let's look at our second equation, which is 2y minus 3 is going to equal 2.5. So in order to solve this, we're going to add 3 to both sides to get that y by itself. And we're adding to both sides. Why, you might ask? Well, to keep the equation balanced and happy, of course. So we end up with 5.5 on the right-hand side, and then we need to get that y completely by itself, so we need to divide 2 from both sides, which leaves us with y equals... Really? What is it with the decimals today, folks? Why do we have so many decimals? So it's going to be 2.75, I believe. 2.5 would be 5 plus 9, yeah. 2.75, so y equals 2.75. And like I said before, you can plug these back in to check your math and make sure it's right. I wouldn't in this case because there's too many decimals and that seems like a lot of work. But it is a good practice to do to make sure you get all the points. So I would recommend it, but, you know, do as I say, not as I do. All right, so third angles theorem. What this says is that if two angles on one triangle are congruent, or two angles of two triangles are congruent, then all three are congruent. And the reason for that is because there's only 3 angles in a triangle and they always add up to 180 degrees. So if our first 2 angles add up to equal 110, then they add up to equal 110 in both triangles, which means that the third angle is going to be 70 in each of them. So the reason for that is, like I said, if you have 2 angles that are the same in a triangle, then the third is going to be the same as well because there's no other variance that could happen. There's not like a 4th and 5th angle that can throw things off. It's just those 2 angles, which makes the third one kind of set because they're going to connect where they connect. So, getting towards the end. So this one's a little funky. We're going to skip it for now because I made a mistake when I was setting up this PowerPoint. It says IJK is the same as IK, or IJK is the same as IKJ. Well, that would be the same triangle. Or no, IJK is congruent to IKJ. If those two angles, an angle. Yeah, so I messed that up. That's my fault. What this should say is it should say IHJ for the second one, because that would make IJK, so this angle, the same as this angle over here. So we're going to skip this example for now. I have faith in all of you that you can all accomplish that. But what we are going to look at, and this is going to be our last problem that we do today is, yeah, because that's a theorem. Yep. So we are going to write a proof. I want to expose you guys to these triangle proofs because they will be on your, oh wow. I just got a notification that Floyd Mayweather is going to fight one of the Pauls, I think Jake Paul, but maybe it was Logan Paul. I don't remember. They're both the same in my opinion. Not a big YouTuber person, but that's going to be interesting. But anyway, we were doing math, so I want to do these proofs. I want to expose you guys to proofs because they are going to be on your test. There aren't a ton of them. They're not brutal, I promise. But it's good to get the practice on them as often as we can since you are going to be assessed on them. And proofs, for as much as we don't care for them, they are a great way to show your knowledge and to demonstrate that you actually have learned what you're intending to learn. So this says, write a 2-column proof. and they tell us that angle L is the same as angle P, angle LM is the same as PO, LN is the same as PN, and MN is the same as OP. What? Really? That doesn't make sense. Line MN is the same as OP. Did I mess this one up too? LN and PN, that makes sense. LM and PO makes sense. LN and PN. Okay, sorry. We got to take a moment because I'm having a hard time wrapping my brain around this. LM is the same as PO. That checks out, 1 hash mark on those. LN and PN checks out, 2 hash marks on those. MN and OP, that is false. That is not correct. So let's fix that. That should be MN and ON. So we're going to fix that boo-boo right there. All right, so MN and ON. That's my mistake. I apologize deeply for that. Kind of. So we have our givens written down. They did that kindly for us. Now, the important thing for us to know here is we have 3 corresponding side lengths. So we know all 3 of the side lengths are the same. Now, we don't know this yet because we haven't learned the theorem for it. But in reality, if you have 3 side lengths on a triangle that are the same, that means the triangle is congruent. We can stop right there because we know that. It's weird. We'll learn about it in the next section. But anyway, fun fact. We know it's true if all 3 sides are the same. But it would be fun to be able to go over that like in person because you can get 3 sticks that are the same length and you can try to make different triangles, and it of course never works. But I like to let kids struggle with that for like 9 to 10 hours, trying to find a different way to make the triangle. But I guess we just won't have the time to do that in class this year. But anyway, so in this case, we are trying to prove that every single side and every single angle is congruent. So with our givens being what they are, my first step personally is I want to prove that this angle here by n is the same on both triangles. And how I plan to do that is using vertical angles theorem. So since these 2 lines are intersecting, line LN and line MN, so since those are intersecting and these angles are directly across from each other, by vertical angles theorem, then those must be congruent. So what I'm going to say is I'm going to say angle LNM is congruent to angle PNO. Congruent to angle PNO. And like I said, that is true based on vertical angles theorem. That being said, I'm going to make a note to myself right now to make a, you know what, I'm not going to make a theorem sheet because I think you guys got this. But on the test, there will probably be a word bank again. So now we know angle L, angle LNM are the same. So let's use real words. So we have 2 angles now that are congruent on each of these triangles, which if we go back to this page, that is third angles theorem. So we have two angles that are congruent. That means the third one must be congruent too. So back to here. So we can say, based on that, angle M and angle O, angle M is congruent to angle O. And we can say third angles theorem. Third angles theorem. I hope I'm spelling theorem right. Yeah. Wish I could write an M though. Okay, so now what we've done is we've proven that all the sides and all of the angles are the same. So you might be wondering, well then, if we've already proved all of that, what's our reason for the last step going to be? Well, it's something that we haven't gone over yet, but we're about to. So there's this lovely thing, which we see on the, oh nope, I lied. So we just completely skipped it, I guess. There's not even a slide on it. Oh, I am such a space cadet. Well, I messed up and I apologize for that. So for those of you who've made it to the end of the video, you get to learn something fun and new. So there's this wonderful, wonderful phenomenon that we in the math world call CPCTC. And that is a acronym. And what that says is corresponding parts of congruent triangles are congruent. So long story short, if all the sides are this, if you have corresponding sides for every side, corresponding angles for every angle, then the triangles are the same, which we kind of hint at earlier, but we just didn't give a name to it. So when we're talking congruent polygons, I think there might have been a congruent triangles slide on here, or I'm losing my mind. So two polygons are congruent if and only if their corresponding parts are congruent. So what CPCTC says is when all the parts are the same, that means the shapes are the same. So that's an acronym that will be our best friend forever and ever and always. CPCTC. CPCTC. It's our hero. CPCTC. Anytime we're trying to prove triangles congruent, guess what that last reason is going to be 99% of the time? CPCTC. I'll say it another 500 times. I'll put out a video and it'll just be me saying it on loop for you. It's like a podcast, but better. All right, so our last page has some more properties for triangle congruence. These might sound familiar. So reflexive property of triangle congruence, that just says that a triangle is the same as itself, so it's congruent to itself. Duh. Symmetric property of triangle congruence says if ABC is congruent to EFG, then EFG is congruent to ABC. So essentially, the symmetric property is still our flip-floppy one. So if x equals 2, then 2 equals x. So it's just flipping it around. Then our transitive property of triangle congruence is the only one that kind of changes a little bit. And it doesn't necessarily change. There's just a lot more writing that goes into it. So what this one pretty much says is that if, I'm just going to label these 1, 2, and 3 for our triangles over here. So what this is saying is if triangle 1 is congruent to triangle 2, and triangle 2 is congruent to triangle 3, then triangle 1 is congruent to triangle 3. Based on that transitive property. So it hasn't really changed either, but it's just a lot more writing.